In this video, I'm going to show you how to use z-scores to find the percentage of data above or below a certain value. In 1999, the scores of men on the math part of the SAT followed a normal distribution, alright, just meaning like a bell curve type of situation, with a mean of 531 and a standard deviation of 115. What percentage of what percentage of men, I am a man, so I guess I could say what percentage of me scored above 750. Now, I'm going to propose using a particular strategy that keeps you organized and on top of things. Now, part of this process, we are going to be using a standard normal probability table, a z-score table. So if you don't have one of these, you're going to need to get your hands on one of these. Alright, first let's just draw a sketch of the situation. So here's a picture of a normal curve, and the mean is 531. So I'll put that right here. Okay. Now we want to know what percentage of men scored above 750. So let's put that on the picture as well. Okay, so 750, I'll just put it over here somewhere. It doesn't matter exactly where, but it's above 531, that's for sure. So 750. Now keep in mind, if we want the percentage of men that scored above 750, we're talking about this part of the graph over here to the right of 750. Alright, let's label this up. These are SAT scores. Now down below here I'm going to do some calculations. Specifically, I'm going to turn this into a z-score and figure out what's going on. This is not part of the thing, but let me just remind you that z-score is going to be the actual score that you got minus the mean divided by the standard deviation. Just keep that in your mind. I'm going to erase that in a minute because something else actually goes here. But so let's turn 750 into a z-score. So if I want to calculate the z-score, I'm going to need to do the actual score of 750, okay, minus the mean of 531, divided by the standard deviation, which was 115. Alright, let's calculate that out. Okay, be careful to round properly, but this, let's do 2 decimal places. This rounds to 1.90. I'm going to even keep the 0 because I really want 2 decimal places for what's going to come next. Alright, now in this section over here, I'm going to sort of redraw this picture in terms of z-score so we can keep track of what we are really doing. Now, in the middle of a z-score chart, the mean is always going to be represented by the number 0. Because any z-score above 0 is going to represent a value that's bigger than the mean. Any negative z-score means how many standard deviations you are below the mean. Alright, so in the middle of a z-score, you always put 0. Now here we have 1.90. That's almost 2 standard deviations above the mean. So again, I'm going to just put that on my picture like this, 1.90, and we are still interested in the percentage of men that scored above 750. Alright, so in terms of z-scores, that's going to be the percentage of z-scores that are above 1.90. So let's calculate that. Okay, so what we are looking for is the percentage of z-scores that are above 1.90. Now, a z-score chart is set up to tell you the percentage of z-scores that are below a given value, not above. So if you want to convert to what percentage is above, you're going to have to subtract from 100. For example, if 20% of the values are below a certain number, that means 80% must be above. How do we get from 20 to 80? Well, 100 minus 20 is 80. You subtract from 100. That's what we're talking about. So, since we want the above values, we're going to have to subtract from 100%. Okay, if we wanted the below numbers, we would just read it straight off the graph. So, let's look at the chart and find out the percentage of values that are below 1.90, and then just subtract that from 100. Now, where is 1.90? So z-score, we've got these negative z-scores. Our z-score is positive, so we're just going to keep scrolling down. Okay, so here we have 1.9. Now, look, the first column is 0. If it was 1.91, we'd go to this column. 1.92, we'd be in this column. 1.93, and so on. But 1.90, all right, we are looking at this number right here. Okay, now translating this to a percentage, that is 97.13%. Okay, so that's what we have to subtract from 100, is 97.13%. All right, just subtract that out. All right, that turns out to be 2.87%. So that's the answer to the question, which I'll record over here. All right, in this space, we tie it all together with a sentence that fully answers the question in the context of this word problem. 2.87% of the men who took the SATs in 1999 scored above 750 on the math part.